Okay guys, so here's the test review video for chapter 10. First off, the test is going to consist of 4 definitions, each worth 5 points, so a total of 20 points. 10 multiple choice. The multiple choice are 3 points each for a total of 30 points, and then there's going to be a bunch of open-ended questions worth 50 points. So there's only like 4 open-ended questions, but there are going to be multiple parts to each one. Okay, so let's do a couple of test review problems. First question, how many moles are there in 36.2 grams of CaO? So, first off, what we want to make sure we do at the top of our exam packet is we draw a mole map. Okay, and we know the tools we need at each step. Between mass and moles, we need the molar mass. Between moles and atoms, we need Avogadro's number, 6.02 times 10 to the 23rd. Okay, so our starting point is 36.2 grams CaO. We're going to go to moles, so we're starting here, we're ending here. It's a one-step unit multiplier. We know that grams will be on the bottom, so grams will cancel out. We're going to moles, moles will be up top. And our final answer is going to be moles CaO. The number which always goes next to mole is 1. And the molar mass of CaO, calcium is 40, oxygen is 16, so we have a mass of 56 grams. If we do our math out, you should get, and correct number of sig figs, 0.646 moles. Okay, the next problem. We're looking at how many grams there are in 2.5 moles of a substance. So our starting point is moles. We want to go to grams. It's a one-step process. So our starting point is 2.5 moles of NaCl. We want to go to grams. So grams will be on top, mole will be on the bottom. 1 always goes next to mole. NaCl is 58.5 grams. 23 for sodium, 35.5 for chlorine. So 2.5 moles of NaCl. We need 2 sig figs in our answer. So our calculator comes out 146.25. However, we need to put that in 2 sig figs. So we're going to round this up to 150 grams. Last question. We have 2.5 moles of boron. And we want to know how many atoms. We come to our mole map and we look at our starting point. Our starting point here is moles. We want to go to atoms. The tool we need to use is Avogadro's number. So we set up our unit multiplier. Mole will be on the bottom. 1 always goes next to mole. Atoms is on top. We know that there's 6.02 times 10 to the 23rd atoms in 1 mole. If we multiply that out, we end up at 1.5 times 10 to the 24th atoms of boron. Those are basic mole map conversions. What I want you to do is try these two. First thing I would do is look at your mole map, figure out how many steps, set up your unit multipliers with units only, then go in and add the numbers, putting 1 next to mole at each step, and then calculate your final answer. These two questions are not one-step questions. I'll give you that hint. Lastly, let's do a empirical formula question. We take each of our percentages and make those grams. We convert each grams to moles. And we divide each by the molar mass. So once we have the moles of each, we're going to divide by the lowest. In this case, the lowest is 0.400. And we generate our mole ratio. And from there, we have our empirical formula. Once we have our empirical formula, we could take this question one step further to find the molecular formula. We'd first need to find the empirical formula mass and then the known molecular mass and divide the two to find the scale factor. We'll try one of those in class tomorrow.